All right, hello everybody. Let's get going here. Monday, lesson 623. Now, this is actually a fun lesson I wish we could do in class. It's really just enjoyable and just kind of a weird, funky one. It actually doesn't use your graphing calculator at all. As you notice with supplies, you do not need it. So that's why we can go ahead and do this lesson. It's tied into what we're doing, but it's just unique. So that's what we're going to focus on today. I do need you to have your homework out because we're going to go over the homework. And then the homework for today is 86 through 90, and that is due Monday by midnight. So make sure you get it done by then. Okay. All right. First of all, please get your homework. And right there, pause the video, please, and check your answers. When you are done checking your answers, you may unpause it, and we'll continue. Okay, so let's go with it. If you had any questions, please make sure you check with me. Send me an email or a comment on here, and I'll try to get it. Okay. Today, 623, why can't studies determine cause and effect? Cause and effect. Now, you've done it in science. You've talked about cause and effect in science, how something causes the other, okay? Today's lesson is this. This is really important. Association is not causation, and that's what we're going to address. A study found that the more hours students spend on activities outside school, the higher their grades tended to be. Does that mean that if you go and sign up for more activities, your grades will go up? Another study found a link between how often you brush your teeth and the reduction of heart disease. Does that mean if you brush your teeth twice a day, your heart will be healthier? As a consumer of statistical information, you need to be aware of the difference between association and causation. Today's investigation will help you explore the difference. Now, the first thing I want you to do is just look at this graph and study it a little bit here, okay? The mayor of Smallville finds the following graph in the town's annual financial report. Please take a second on your paper and describe the association, if any, in the scatter plot. When you are done, unpause and we'll continue. All right, so the association, hopefully you found that it was probably something a little like this, okay? There definitely seems to be a linear, positive association. It's going up, linear positive, and it's fairly strong. I'd probably say moderate. Okay, so linear, strong, or linear, moderate, positive association with no really outliers. The mayor immediately orders the fire department to send fewer firefighters to each fire so that there is less damage. Why do you think the mayor would say this? Do you agree with the mayor's decision? Explain why or why not. So look at it. The mayor said, hey, we're going to send, the bigger the fire, the less firefighters we're going to send. All right? So what do you think? Now, here's the funny thing. Now, as you can see, what's going on here, the more firefighters go to the fire, the bigger the damage seems to be. Isn't that what this shows here? You know, we get more firefighters and more damage. So does that mean they should send less firefighters? And the problem is, even though there is some logic to this, it wouldn't work. Why would more firefighters cause more damage? Or why would there be more damage where more firefighters go? Because it probably means the fire is even bigger. So the mayor read this information wrong. They should have said, hey, the bigger the fire, the more firefighters go. So there is a link, but it's not a cause. The firefighters don't cause the problems and the damage in the fire. Okay, how about this other one? 681. A dietitian studying the benefits of eating spinach surveyed a large sample of individuals. She recorded the amount of spinach they ate and their physical strength. The dietitian found the spinach eaters to be much stronger than the non-spinach eaters. The next day, the newspaper headline was, Popeye was right, eating spinach makes you stronger. Do you agree with the newspaper? Do you agree that if you eat more spinach, you will grow stronger muscles and increase your strength? Please go ahead and pause and write down an answer to this and tell me what you think. Okay, so here's the thing. Does eating spinach make you stronger? Probably not. Even though spinach is very healthy, it's not going to just by itself cause your muscles to grow. And that's where we're getting to the second part right here. The dietitian correctly found an association. There is some type of link, but what could explain this association other than spinach makes you stronger? What do you think? Think about it for a second. Okay, do you think you've got an idea An idea of what might do it? Well, here's the thing. I don't know how many of you eat spinach. Not everyone does. However, it does seem to be that those who eat spinach, what in general might be true about their lifestyle? Okay. In general, those who would prioritize eating spinach because it's good for you are more concerned about their health and maybe the type who are going to go out of their way to do exercise, to work out, to eat other healthy things. Okay. So there is maybe some other things that could explain why someone eating spinach may be stronger. It's not directly the spinach, or not necessarily directly the spinach, but it's just a lifestyle that someone who eats spinach might take. And that's what leads us to this problem. Problem 682. A lurking variable. Please write that down. Lurking variable. Lurking is like hidden, okay? So hidden or lurking variable is a hidden variable that was not a part of the study. The size of the fire in problem 680 and the amount people work out in problem 681 are lurking variables. So again, the size of the fire, that's what's going to kind of determine how many firefighters usually go to a fire and therefore the amount of damage. The amount people work out might be what actually causes the weight or the strength gain versus more the spinach. Okay, so let's look at this one. A medical study found a strong link between the number of hours high school students wear a helmet and the number of concussions or head injuries. However, it is unlikely that wearing a helmet actually causes head injuries. Can you think of a lurking variable that might explain this association? So pause the video and actually take some time and think about a lurking variable and write it down in your paper, please. All right, so yes, wearing helmets will hopefully not, cause concussions. What would actually be a lurking variable to cause concussion? Probably the fact that people who wear helmets are probably doing some extreme sports or sports that would require, or activities that would require protection for your head, and therefore even wearing a helmet can only help prevent concussions. It can't stop them completely. So someone playing football or someone driving a car, they still might get into car accidents or injuries that might cause concussions more than someone maybe playing, I don't know, a video game at home or playing golf. They're less likely to wear helmets and therefore less likely to have concussions because of that situation. So the lurking variable is more the activity that they're involved in that might require a helmet versus actually the helmet causing concussions. So is this all making sense? I know it sounds very obvious. You're just like, this is really dumb, Mr. Ramirez. I get it. But it's really important that you understand that the association, there is a strong link with the people wearing helmets and concussions, but it doesn't mean that wearing a helmet causes concussions. Association is not causation, okay? Doesn't mean that it doesn't mean that just because they're associated that it never causes, it just means that it doesn't automatically mean it causes it. Let me prove it even more. Here we go. Problem 683. A web of associated variables can get complex and be difficult to unravel. Consider a medical study focused on hearing loss. It may associate variables like eating prunes to hearing loss as strongly as it associates an actual cause like long-term noise exposure to hearing loss. So you see all this stuff right here. Okay, look at all the stuff in the middle here. Now, the primary thing is just, I don't know how well aware you are of this, but senior citizens, yes, have a tendency to have gray hair, have a tendency to have or long-term noise exposure, maybe because they're older, but they also tend to have false teeth. A lot of them tend to eat prunes, and if you have no idea what that is, it's because prunes help you with digestion. Let's put it that way. And so all of those kind of have, look at this, cause, yes, as you get older, that does seem to cause gray hair. As you get older, you have longer term noise exposure because you've lived longer, so you're more likely. But which ones of these are cause? Okay, does long-term noise exposure cause? See that? Cause hearing loss. Gray hair doesn't cause hearing loss, okay? That's just an association. If you're older, you might have gray hair, you might have hearing loss. I mean, look at this newspaper right here. Hearing loss caused by false teeth. No, okay? It doesn't mean that it causes it. It just means there's a link between them, okay? So here are some newspaper headlines from actual observational studies. So what you're going to see below is some headlines from actual observational studies. Each of them found an association Some even imply a cause and effect relationship. So they might imply causation, but it doesn't mean they're actually true. Okay? So, determine at least one plausible lurking variable that could explain the actual cause. Calcium in diet may cut risk for some cancers, study finds. B, study. Family time declines as web use booms. And C, chocolate is linked to depression. So please try to find at least one variable for each, lurking variable for each of these. So pause the video and then write one for each one, and hopefully they're good. We'll see. We'll see what you come up with, okay? All right, and then I will share with you. Okay, so hopefully you paused it and you came up with a lurking variable. All right, let's look at some possibilities. Now, doesn't mean that this is definitely a cause or an causation, but here we go. For the first one, calcium in diet may cut risk of some cancers. It is possible that young people have more calcium in their diet and young people get less cancer. So the more calcium in your diet, usually younger people drink more calcium, drink more of that, and have less cancer. Okay. So it also might be, again, that someone who drinks more calcium, makes a point to drink calcium in their diet, may be aware of other healthy, conscious things like exercise and avoid smoking that would kind of cut your risk of cancer. Okay. B, study family time declines as web use booms. So here's the thing. The world is becoming more technologically oriented. However, like fast food consumption is also booming. Perhaps it is causing fewer families to eat together, and so they spend less time together. Maybe families with lots of activities use more technology and have less time to spend together, so the activities are the cause. So it's not necessarily that the more you use the internet, the less time you spend together, but a lot of times internet is kind of independent use, isn't it? You do it alone. You don't necessarily do it with family time, okay? And the last one, chocolate is linked to depression. No, for the most part, chocolate is not linked to depression. But it could be that people who are depressed do eat. A lot of people are known to eat chocolate. It's a comfort food, so they eat chocolate when they're depressed. And therefore, that might be an association versus or a causation or lurking variable. Is that it's a comfort food that people do eat with depression or do eat when they're depressed. So it's not that eating chocolate is going to cause depression. Okay. All right. Now that might not be the only one, but I'm just kind of throwing out some ideas. So just, again, be familiar with that. Okay. All right. So that was it. And it would have been fun. Like I said, it would have been fun to kind of discuss it in class. It's a fun lesson. Unfortunately, I'm sure some of you came up with some pretty kind of crazy lurking variables or other ideas, and you might even have some other opinions. There are some fun ones. Like one of them is another one that you were supposed to come up with, like problem 684. They wanted you to come up with your own form or your own link and association. So one of them was bathing suits tied to sunburn. So doctors recommend swim naked. Yeah, no, that's not probably something that should happen. But it's just interesting how people in our world today take an association and assume that it is causation. Please be careful with it, okay? All right, so this Math Notes box here is about residual plots. I know we haven't gotten a chance to talk too much about residual plots. We will work more on residual plots tomorrow and the rest of this week. So if you are confused, feel free to please pause the video and read this data on residual plots, okay? That is it for today. Please make sure you read the homework or read and do the homework. And there is a Foxtrot. We haven't done it in a while. But have a wonderful day. Have a wonderful weekend. And I will see you at some other time.